In nuclei, next topic is law of the radioactive decay. Suppose a sample of the radioactive nuclei has N0 nuclei at time t equal to 0, and after some time the remaining nuclei undecayed are N at time instant t. These are the number of undecayed nuclei. Then as per the law of radioactive decay, the rate of decay of the nuclei, this is the minus dN by dt, minus refers the number of the nuclei undecayed decreases with the time, is proportional to the number of the nuclei remaining at particular instant. So if we take the proportionality constant turn into the equality, we will write dN by dt is equal to a proportionality constant lambda into n, where lambda is the decay constant. Now solving this expression, we will have minus dN by n, bringing this n on the left hand side and equal to lambda into dt. And on integrating, we will have integral minus dN by n, that is equal to integral lambda dt plus c. C is the constant of integration. This implies that this minus is taken out of the integral, so remaining is integral dN by n equal to lambda is a constant, so it is also taken out of the integral and remaining is integral dt plus c. This implies that minus integral of 1 by n is log n with base e, that is equal to lambda into integral of dt is t plus c. Now to find the value of constant of integration, we use initial condition that at t equal to 0 it is given that n equal to n0. So we will have minus log n0 equal to 0 plus c, or c is equal to minus log n0. Substituting the value of c, we will have minus log n equal to lambda t plus, and c is minus log n0. This implies that log n minus log n0, that is equal to minus lambda t. These two can be clubbed using the property of log and can be written as log n by n0, that is equal to minus lambda t, or n by n0 can be written as e raised to the power minus lambda t. This implies that n equal to n0 e raised to the power minus lambda t. Here n0 is the number of the undecayed nuclei at time t equal to 0. N is the number of the undecayed nuclei at the time instant t, and lambda is the constant which is also called decay constant. Using this expression, we can find the half-life of the radioactive sample. Half-life of a radioactive substance is defined as the time interval in which the number of the radioactive nuclei reduce or disintegrated to the half of its initial volume. That means T will be the half-life. This implies that the number of remaining undecayed nuclei will be initial divided by 2, that is the half of the initial undecayed nuclei. Substituting these values, we will have n0 by 2, that is equal to n0 into e raised to power minus lambda t, or we can write it is 1 by 2 because n0 get cancelled, it is equal to e raised to the power minus lambda t. Or we can write 2 raised to power minus 1, that is equal to e raised to power minus lambda t. Taking the log on the both sides with base e, we will have minus 1 log of 2, that is equal to minus lambda t log of e. This will be 1 because base and the argument are the same. Therefore, we will have minus log 2, that is equal to minus lambda t. And minus get cancelled. So this T is now here because we have considering the half-life when the sample remains n0 by 2. So it is the half-life period represented by T1 by 2. This is the half-life. Therefore, T1 by 2 will be equal to log of 2 divided by lambda. If we substitute the value of log 2, it will be 0.693 divided by lambda. Therefore, if we know the decay constant lambda, we can find the half-life of the radioactive substance. Similarly, we can define the decay constant lambda. Decay constant is the reciprocal of the time duration in which undecayed radioactive nuclei reduces to 1 by E times of the nuclei present initially. That means lambda will be equal to 1 by tau. This is the time period for which remaining undecayed nuclei will be 1 by E times of the initially present undecayed nuclei. Here, this tau is also known as the mean life of radioactive nucleus. Therefore, now substituting the value of T equal to tau, that is the mean life for which number of the undecayed nuclei becomes 1 by E times of the initial number of nuclei, we will have, using the equation n equal to n0 e raised to power minus lambda t, it will be n0 by e equal to n0 e raised to power minus lambda tau. This n0 get cancelled, so e raised to power minus 1 equal to e raised to power minus lambda tau. Comparing this equation, we will have lambda tau equal to 1 or lambda equal to 1 by tau. This also can be written as tau equal to 1 by lambda. It gives the mean life of the radioactive substance.